Imagine standing on a silent Martian plain, feeling its ancient stillness beneath your feet. This quiet world once held far more energy than its frozen surface now suggests.
For billions of years, Mars carried a magnetic shield, much like Earth's protective field. That shield guarded a thick atmosphere where warm winds once moved across open water.
Then something changed. Something powerful enough to silence an entire planet's heartbeat.
Scientists now search the rocks for clues, like detectives studying long-faded fingerprints. Deep in the crust, minerals carry a whisper of Mars's lost magnetic strength. These clues tell us Mars was not always the barren world we see today.
Then, in 2022, the planet spoke again, through the strongest quake ever recorded there.
The signal circled Mars for hours, like a drumbeat echoing through hollow stone. At first, Middle Eastern scientists suspected a meteor strike as the source of the powerful tremor. But no crater appeared, forcing us to look inward, deep beneath the red dust. The quake revealed something unexpected. Mars is still shifting, still alive in its own way.
Its motions are slow, but they prove the planet never fully went silent.
The seismic waves held a secret, one hidden in their sudden change of speed.
That change pointed to one astonishing possibility: liquid water beneath the crust. 10 to 20 kilometers down lies a vast, planet-spanning reservoir. If brought to the surface, it could blanket Mars with an ocean a kilometer deep.
This idea overturns long-held beliefs about Mars's dry and frozen history.
Water is the fundamental ingredient that shapes chemistry, climate, and potential life.
So how did this underground ocean survive for billions of years?
One theory suggests surface water slowly sank as the atmosphere thinned.
Another proposes minerals locked water inside before releasing it again. Both lead to a powerful truth. Mars preserved far more than we expected. Hidden water also raises a deeper, timeless question about life. On Earth, microbes thrive in deep darkness, living on chemistry alone.
Could Mars harbor anything like that in its buried ocean? We cannot yet know, but the conditions no longer seem impossible. This ocean may be the final missing chapter in Mars's climate evolution.
Studying it could reveal how the planet transformed over billions of years.
Was Mars once fully blue, or only briefly wet before fading into desert? Did its climate collapse slowly, or end in a single dramatic event?
Only the hidden ocean knows the full story beneath the dust.
Reaching it will require technology far beyond today's capabilities.
Even on Earth, drilling that deep pushes engineering to the limit. But discovery rarely waits for perfect conditions. It waits for persistence.
Each mission brings us closer to understanding Mars's hidden interior.
Future sensors might map the ocean like a planetary ultrasound.
And one day, advanced drills may finally touch the ancient water below.
If life ever escaped downward, we might be the first to find its clues.
Mars proves that even quiet worlds can hold extraordinary surprises.
Exploration is not just about reaching far places, but about looking deeper.
We now stand at the edge of one of humanity's most profound questions.
Did life emerge only once, or many times across the cosmos?
If Mars holds even a whisper of life, the universe becomes less lonely. That is why every signal and every quake matters more than it seems.
Even the faintest tremor can reshape how we see our own origins.
With each discovery, Mars feels less alien and more like a distant relative. Our stories may share more chapters than we once believed.
This is why our search continues with patience and curiosity.
Somewhere beneath that red dust lies our next great discovery.
Now our intro fades, and we descend into Mars's secret interior.
Stay curious as we explore the science behind this planet's quiet pulse. Marsquake signals show a world still bending and stretching within.
This subtle motion hints at inner energy we barely understand.
Planetary science often begins with a simple question about what lies below.
For Mars, the answer is more dramatic than anyone expected.
Water changes everything. It fuels chemistry and possibility itself.
And Mars may hold far more water than we once imagined.
Each breakthrough brings us closer to understanding how planets evolve.
The cosmos is vast, but discovery becomes brighter when explored together.
Thank you for watching, and I'll see you on our next journey among the stars. Imagine standing on a frozen Martian plain where silence feels older than time itself. The world looks dead, yet something beneath the surface hints at a deeper story.
Have you ever wondered what truly lies under that silent Martian crust?
Mars may not be lifeless, but simply sleeping beneath its blanket of red dust.
Even the quietest planets can hide ancient rhythms of geological motion.
Mars behaves like a world in deep hibernation, rather than one fully extinguished.
Beneath the cold soil, tiny shifts reveal a planet still slowly breathing.
These movements suggest Mars retains energy far greater than its surface implies. Then came the discovery that shattered our assumptions about this barren world.
Deep below Mars lies a vast layer of liquid water, hidden for eons. Liquid water, where none should exist, changes the entire Martian story.
Imagine an ocean large enough to drown the entire planet under a kilometer of water.
This underground reservoir is one of the strangest Martian paradoxes ever found. Pressure and geothermal heat keep the water liquid, despite the frigid surface.
Similar hidden lakes exist under Antarctica, preserved by pressure alone. If it can happen on Earth, why not on Mars, with its ancient heat still trapped inside?
Eliteless. The question is how such liquid water survived billions of years of planetary cooling.
Some theories suggest ancient lakes seeped downward as the atmosphere thinned.
Others propose minerals released stored water as Mars continued cooling.
Whatever the cause, the existence of this water changes everything.
But how did we even discover something hidden so far below the surface?
The answer comes from a quiet machine, built not to see, but to listen.
InSight has no wheels or cameras, only the most sensitive ears ever sent to another world.
It listened to the planet's subtle tremors, like a Caucasian male doctor hearing a patient's heartbeat. Each vibration carried clues about the layers buried beneath the crust. One day, a strong Marsquake sent ripples around the entire planet. InSight captured every movement, revealing something dense, warm, and liquid below.
Those patterns matched one substance better than anything else: liquid water.
It was the first real map of Mars' inner world, drawn only by sound.
For the first time, we could imagine Mars not as dead, but deeply complex. A planet frozen above, yet active below, challenges everything we thought we knew.
What else might be hiding beneath 20 kilometers of ancient stone?
Could chemical reactions there support tiny forms of life, as they do on Earth?
Deep Earth microbes survive without sunlight, feeding on minerals alone.
So if Mars has warmth, water, and chemistry, what prevents life from existing there?
We might not find cities or forests, but simple life is another question entirely.
Mars could hold clues to whether life is rare or common in the universe.
And all it took was listening carefully to a world many believed was silent. InSight proved that even a still planet can whisper truths from its interior.
Its data gave us the clearest picture ever of Mars' hidden heartbeat.
Now we know Mars isn't a dead rock, but a world with stories still unfolding.
Understanding that story may reveal how planets evolve, survive, or fade away.
And perhaps it shows how fragile and rare active worlds like Earth truly are.
Mars reminds us not to judge a world by the silence of its surface.
Its greatest secrets live in the places our eyes cannot see. With future missions, we might one day touch that underground ocean ourselves. Reaching it would be one of humanity's greatest engineering achievements. But until then, every small measurement helps us sharpen the story. Every quake tells us something new about the planet's hidden engine. Each discovery turns Mars from a distant world into a familiar neighbor. And that brings us back to the question at the heart of all this.
If a sleeping world can hold an ocean, what else might it protest in the dark?
The mystery will guide science for decades, reshaping how we explore. Perhaps the answers lie deeper than we ever imagined.
Our journey is only beginning, and Mars is just starting to speak.
The cosmos is vast, but discovery grows brighter when shared together. Thank you for watching, and join us again on our next journey among the stars. Imagine standing on Mars, where silence stretches farther than the horizon. The surface looks lifeless, but the story below is far more interesting. Have you ever wondered what lies deep under this frozen desert?
Mars may hide more life underground than it ever had on its surface.
On Earth, life survives deep below where sunlight never reaches.
Those organisms live on chemistry, not sunlight, thriving in pure darkness.
If Earth can support deep life, Mars might do the same in its buried layers.
Imagine organisms adapted to dark, stable conditions far beneath the red soil.
These microbes could be remnants from Mars's warm and watery past.
When Mars dried, life may have followed the water underground.
As the atmosphere vanished, surface life could have retreated below.
Underground, pressure and temperature remain surprisingly stable. Stability is the key ingredient for survival in extreme environments.
If life needed refuge, the deep subsurface was its safest option.
Water still exists down there as liquid, not ice, protected by pressure. Liquid water means chemistry continues even when the surface freezes. At depths where Earth sustains life, Mars might nurture it too. Could ancient Martian microbes still persist in this hidden world? Life here would be tiny, tough, and nearly invisible.
Perhaps evolution pushed Martian life deeper as the planet cooled.
Survival may have meant abandoning the surface entirely. What if Mars is alive, just not where we expected? Signs of activity beneath the crust strengthen this possibility. Marsquakes show the interior still moves despite the frozen exterior.
These quakes prove Mars holds more internal energy than assumed.
Even small movements can sustain environments suitable for microbes.
Active geology means heat remains, and heat can keep water liquid.
Life needs water, chemistry, and stability, all possible below Mars.
Unlike the surface, the deep underground avoids deadly radiation. Darkness is not a barrier to life, but a shelter from destruction. If life endures,
it likely adapted to darkness long ago. Imagine ancient organisms clinging to warm rock as Mars cooled.
These survivors might still persist today, unchanged for eons.
The deep subsurface could be Mars' most stable habitat.
Life thrives in stability, even if everything above collapses.
Marsquakes help us map these hidden regions, like planetary sonar.
Each quake reveals pockets where heat and water still interact.
This interaction could power tiny ecosystems the size of grains.
If so, Mars may host the simplest form of life imaginable.
The crust continues to crack, creating new pathways for water.
These channels might allow chemistry to flow across miles.
Even limited movement keeps underground habitats alive.
Mars is not a frozen relic, but a world quietly reshaping itself. Beneath stillness lies a restless interior, moving inch by inch.
This movement produces heat that microbes could depend on.
Heat rises upward, feeding tiny reactions in the dark.
Life here would be microbial, patient, and incredibly durable.
If Mars ever had life, this is where it would retreat to survive.
Retreating underground may have saved entire microbial lineages.
Earth's deep life teaches us survival never requires sunlight.
Mars could repeat that same biological story in its own way.
Imagine the planet hosting pockets of life no camera can see.
These pockets might persist for millions of years without change.
Marsquakes occasionally shake these worlds, but do not erase them. The crust shifts slowly, renewing the environment bit by bit. Even tiny shifts can deliver nutrients across deep spaces.
The deeper we stud Mars, the more alive it begins to feel. Life may not live on Mars's surface, but beneath it, hidden from view.
Mars challenges our assumptions about where life can endure.
If life survived, it chose safety over sunlight.
The planet still moves, still resonates, still breathes.
And that movement might keep underground habitats alive today.
Mars is quiet, but its silence hides a world in motion. Deep below, chemistry still dances in slow, patient cycles.
What if life exists not above, but below, waiting for discovery?
Perhaps Mars's greatest secret is not its past, but its present.
One day, we may drill deep enough to find what hides in the dark. Until then, Marsquakes reveal hints of unseen worlds below.
Imagine standing on Mars, wondering what lies deep beneath your feet. The surface looks quiet, but the real story is hidden below.
Have you ever wondered how we could reach an ocean buried kilometers below?
The challenge is enormous, even compared to Earth's drilling attempts.
On Earth, deep drilling requires immense power and stability.
Now imagine trying that in freezing winds and thin air on Mars. Mars lacks the atmosphere and resources that support deep drilling here. Even our most advanced drills struggle past a few kilometers. To reach Mars's hidden ocean, we'd need technology that doesn't exist yet. Think of it like trying to dig through a frozen planet using tools from yesterday. Transporting deep drilling machinery across space is another massive hurdle.
Each ton adds complexity, energy demand, and astronomical cost.
Even if we delivered everything, Mars cold would freeze most systems instantly.
Planet's dust can infiltrate and shut down delicate mechanisms.
So how do we explore something buried 20 kilometers underground? We listen, just like African-American male doctors listening for clues inside the human body.
Sound travels differently through rock, water, and empty space. By reading these shifts, scientists map what lies far below. Marsquakes give us the clearest picture yet of its interior.
These signals show pockets of liquid water deep underground.
Liquid water on Mars today changes the entire narrative.
Mars is not just a cold relic, but a world holding hidden potential.
If water survives below, the environment may support simple chemistry.
And chemistry, over time, can shape the building blocks of life.
So what if something small, ancient, and tough still lives there?
We're not expecting forests or animals, just resilient microbes.
These organisms would rely on mineral reactions, not sunlight.
The deep underground protects them from deadly radiation above. Warmth from the planet's interior could keep them alive.
Even small movements in the crust help nutrients circulate.
That's why Mars's interior activity matters more than its frozen surface.
Mars still shifts, cracks, and releases energy from within.
Each Marsquake proves the planet hasn't gone fully silent.
Such motion hints at warmth and fluid pathways underground.
Where water and heat meet, possibilities expand dramatically.
Mars forces scientists to rethink almost everything they assumed.
The planet, once written off as dead, now appears strangely alive.
Its hidden ocean suggests a world with long-term stability.
Stability is exactly what simple life needs to endure.
Even after billions of years, pockets of life might still cling to warm rock.
This possibility turns Mars from a relic into a candidate for biology.
Scientists now view Mars as a world worth rereading, not discarding.
Each new discovery paints a richer story of this complex world.
Mars is not simply history. It may still hold ongoing processes.
This forces science to rewrite Mars as a world of potential.
Potential for hidden water, hidden heat, and maybe hidden life.
Exploration now shifts from the surface to the deep unknown.
The greatest discoveries may lie far beneath what we can see.
One day, advanced drills might reach the ocean we only hear today.
That moment could redefine our place in the universe.
For now, each quake brings us one step closer to answers. Mars teaches us that silence can hide extraordinary secrets.
And those secrets might reshape humanity's understanding of life.
This is why Mars continues to captivate scientists worldwide.
It is no longer just a barren world, but a world of possibility.
Mars still has many chapters left to reveal, and we're listening.
The cosmos is full of mysteries, but this one is close enough to touch.
Together, we'll follow the clues hidden beneath the dust.